Every installer will tell you the same thing. Switch to a heat pump and cut your energy bills in half. And they're not lying, but they're not telling you the full story either, because that saving is only real if your house meets specific technical conditions. In this video, I'll show you exactly what those conditions are, how to check if your house qualifies, and what happens to your bills if it doesn't. Let's start with why installers love the savings pitch. A heat pump doesn't burn fuel. It moves heat from outside air into your home. For every 1 unit of electricity it consumes, it delivers 2 to 4 units of heat. A gas boiler, by comparison, converts 1 unit of fuel into roughly 0.9 units of heat, even the most efficient condensing models. On paper, the heat pump wins easily. But here's what that calculation ignores. Electricity in the UK costs roughly 3 to 4 times more per unit than gas. So your heat pump needs to deliver at least 3 units of heat per unit of electricity just to break even with a gas boiler. That ratio is called the COP, coefficient of performance. And whether your system actually achieves that number depends almost entirely on one thing: how well your house is insulated. A well-insulated house needs low-temperature heat, around 35 to 45 degrees Celsius in the radiators or underfloor system. Heat pumps are extremely efficient at producing low-temperature heat, but a poorly insulated house loses heat faster than it can be replaced at low temperatures, so the system has to work harder, the flow temperature rises, and the COP drops. The savings disappear. So before any installer quotes you a heat pump, the first question should be, what's the heat loss of this house? Not the size of the house, not the number of bedrooms, the actual calculated heat loss in kilowatts. If they can't answer that, walk away. There are 2 conditions that together turn a heat pump from a money saver into an expensive mistake. The first is poor insulation. A house that hasn't been upgraded, single glazing, no wall insulation, minimal loft insulation, typically has a heat loss above 10 kilowatts. To heat that house with a heat pump at low flow temperatures is almost impossible in winter. The system will either underperform or switch to an expensive electric backup element to compensate. That element runs at COP1, meaning you're paying full electricity price for heat, which is the worst possible outcome. The practical checklist is this: your loft should have at least 270 millimeters of insulation. Your walls should be insulated either internally or externally, or have filled cavity insulation, and your windows should be double glazed minimum. If any of these are missing, insulate first, then consider a heat pump. The second condition is electricity price. In the UK right now, electricity costs roughly 24 pence per kilowatt hour. Gas costs around 6 pence. That's a ratio of 4 to 1. For a heat pump to be cheaper to run than a gas boiler, it needs a real-world COP above 4. In a well-insulated modern house, that's achievable in spring and autumn. In winter, when outdoor temperatures drop, it becomes very difficult to sustain. If you're on a standard electricity tariff and your house isn't already well insulated, the honest answer is that a gas boiler will cost you less to run right now. That may change as electricity prices fall relative to gas over the next decade. But that's a forecast, not a guarantee. Here's where the sales pitch and the reality diverge most clearly. Most installers and manufacturers quote a COP of 3 to 4. That number is technically accurate under laboratory conditions at an outdoor temperature of around 7 degrees Celsius with a flow temperature of 35 degrees. That's the standard test condition called a 7/W35. It sounds reasonable for the UK, but it's not representative of a UK winter. In January, overnight temperatures in the UK regularly drop to -3 degrees Celsius. At that outdoor temperature, with a flow temperature of 45 degrees, which is what most existing radiator systems need, a real-world COP is closer to 2, sometimes lower. What does COP2 mean in practice? For every pound you spend on electricity, you get 2 pounds worth of heat. A modern condensing gas boiler gives you 90 pence of heat per pound spent on gas, but gas costs 4 times less. So at COP2 on electricity, your heat pump is actually more expensive to run per unit of heat than your gas boiler. Not by a dramatic margin, but enough to matter on an annual bill. The solution isn't to avoid heat pumps. The solution is to design the system so the flow temperature stays low even in winter. That means either upgrading radiators to larger surface area models, adding underfloor heating, or, ideally, doing both alongside proper insulation. A correctly designed system in a correctly prepared house will sustain a COP above 3 even in cold weather. But that requires a proper heat loss calculation, a proper hydraulic design, and an installer who is willing to do that work up front rather than just fitting the unit and leaving. So here's the honest summary. Heat pumps work. They can genuinely reduce your bills and your carbon footprint, but they only work well in houses that are prepared for them, and most houses in the UK are not there yet. Before you sign any contract, ask your installer for a full heat loss calculation for your property. Ask them what flow temperature the system will run at. Ask them what COP you should realistically expect in January. If they can't answer those three questions with specific numbers, you're not talking to someone who will give you a system that performs. If you want a simple checklist to run through before your installer appointment, I've put one in the description below. And in the next video, I'll walk through what a proper heat loss calculation actually looks like and how you can do a rough version yourself before anyone sets foot in your house.